Hello, this is Mr. Collier, and today we're doing arithmetic sequences. Okay, so let's take a look at a sequence of numbers. This particular sequence, you notice the numbers, or the terms, we should call them, are increasing by 4 each time. And that's the definition of an arithmetic sequence. Arithmetic sequence. Okay, it's increasing by a constant amount. Okay, but another way to think about it is if you subtract terms, like a term subtract a previous term, you always get a constant number, in this case 4. Okay, so that's one way to think about it. Actually, let's go over here. So we got this increasing by 4. It's an arithmetic sequence, so let's take a look at some properties of this arithmetic sequence. And these numbers represent cubes in context. That's not important right now. But yeah, the numbers are increased by 4. So notice, like I said, yeah, it's increasing by 4 each time. So if you want to get 13, you actually could do 1, the starting value, plus 4, plus 4, plus 4, because you're increasing by 4 each time, and that gives you 13. Okay? So we've got some formulas in our formula booklet that use the same strategy to give us the value of the term. Okay? So notice I added 4 3 times. So it's like 1 plus 3 times 4. And the number of terms in this sequence here is 4. So you could write it as like 4 minus 1 times 4. 3 is 4 minus 1, right? And that's where the formula basically comes from. So let's take a look at the formula for the nth term of an arithmetic sequence in our formula booklet. It's un equals u1 plus n minus 1 times d. That's what we just did. We did u1 stands for the first term, n minus 1 is the number of terms minus 1, and we did 4 minus 1, and d is 4 in this case. Okay, so this is a formula that will give us the value of any term in the arithmetic sequence. Okay, so if you want 10th term, you would do logically you do 1 plus, we'd be adding 4 9 times. So this is what you get. 36 plus 1 is 37. Okay, using the formula, you would write it like this. Now let me write out the formula from the formula booklet again. Plus n minus 1 times d. What we're getting is u10. That means the 10th term is the first term, which is 1, plus the number of terms is 10, and the d value is 4. That's the common difference. D equals 4 in the formula. And that is exactly what we just did over here. It's 37. Okay? So you can do the same thing here. U100 equals first term plus n minus 1 is 99 times 4. And that, well, 4 times 99 is like 400 minus 4. So it's 396 plus 1 is 397. Okay, that is how the formula works. Sometimes we might be given another piece of information. You might have to solve for u1 or n or d or something like that. Okay. So let's look at, sometimes we're given a simplified expression, and we have to maybe figure out some other information. Alright, so we can, it's asking us here to sub in 1, 2, and 3, so let's do it like this. Let's make an organized table. 1, 2, 3, 4. I substitute in 1 into this expression, I get 4. Substitute in 2, and I get 7. So you can see this is arithmetic, which makes sense. This is like the equation of a line with a slope of 3, so it's going up by 3 each time. Yeah, so it's going to give you an arithmetic sequence. As long as n is not squared or anything, you'll get an arithmetic sequence. What's the value of d, called the common difference? Well, that's obviously 3, and it corresponds to that number there. Okay, given that you know u1 and d, use your answer to write, given the last section, make your own expression for un. So using the formula from the booklet, we have the first term, which is 4, plus n minus 1 times the common difference is 3. So this is the same thing as this one. If you expand the brackets and simplify, you get this one here. So it is equivalent.